So this is the satellite communication. So we have some drawbacks with the microwave systems. That is, what drawbacks we have with the microwave system? If any obstacle comes between transmitting station to the receiving station, the data may be lost. That means the message may be lost or the communication may be lost, or the speed of the message will be decreased. So what we are requiring? We are requiring many number of transmitting stations between transmitting station to the receiving station, and many number of repeaters are required. So we are using radio signals in the microwave systems. So the many number of radio stations are required. That means stations to transmit and receiving stations are required, as well as repeaters also required. So if you have the sender and receiver is in a long distance, there are many number of repeaters. Each and every repeater must be distance between 25 to 30 kilometers. For example, consider I want to send a message from Nizamabad to Hyderabad. How many number of repeaters are required? Hundreds of repeaters are required. So what will happen? The cost of the microwave systems is going to be increased because of the repeaters. Okay, so and the speed is also maximum 16 gigabytes only. The speed is also less, cost is also high, many number of repeaters are required. If any obstacle comes, so the data may be lost. So we have many number of drawbacks with the microwave systems. So we introduced the next communication devices are the satellites. So what are the satellites? It looks like an umbrella which is at a transmitting station, and at the same thing, and the receiving station also have some umbrella. In that the signals can be transferred through the space, that is also wireless, such as your microwave systems. So microwave systems, satellite communication systems are wireless communication systems only, but we have many number of drawbacks with the microwave systems. To overcome that only, we are introducing the satellite communication systems. Okay, here in the transmitting station, you have an umbrella type thing, that means network device that transmits a signal through the space. That links, that signals are meets in the satellite, right? That is very long distance from the transmitting station. That signals transferring from transmitting station to the satellite called as uplink, whereas the signals received by the satellite and it transfers the signals to the receiving station, that we call it as downlink. Uploading, downloading. Uploading means what? Sending. Downloading means what? Receiving. So this works in the satellite communication system. So in this satellite communication system, you can transfer the signals at 6 gigahertz or to the 14 gigahertz. That means you can transfer the signals in this way to the 6 gigahertz speed to 14 gigahertz speed. That means it's a very high speed data you can transfer using the satellites, right? And it can transfer the signals and it becomes weak due to 30,000 kilometers long distance. So you are sending the signals to the satellite. There also you get some obstacles. Now what will happen after going some distance? That distance is what? 36,000 kilometers. After going 36,000 kilometers, the signals may be weak. So a transponder mounted on the satellite amplifies the weak signals and transmit it to the earth at a frequency of 4 or 11 gigahertz. So on the satellite we have a transponder. So as we have requiring repeaters, in that what we have here? We have transponder. So what is transponder? This transponder is situated in the satellite, right? On the satellite, this transponder takes the signals from the transmitting station and it amplifies it. For example, 6 gigahertz speed is going. After reaching 36,000 kilometers, a transponder is placed, what it does, this transponder takes these signals and amplifies it and gives to the satellite, and satellite will send the response back to the receiving station with the speed of 4 gigahertz to 11 gigahertz. So sending speed is 6 to 14 gigahertz. Receiving speed is 4 to 11 gigahertz in the satellite communication systems. Clear? So we have many number of advantages and disadvantages with the satellite communication system. So what the advantages we found? So advantages are, it is very speed, right? Speedily you can transfer the data from sender to the receiver, and there are no obstacles between the sender and receiver. If you have any number of obstacles also, there is no problem in the satellite communication system, because we have a transponder on the satellite. So the transponder takes the data from the sender and it amplifies it and it sends to the receiver station. And error detection is trivial in the satellite communication systems. So there will be no errors, as it is whatever the message you are sending from sender to the receiver, that is reached without any error. So there will be no error in this communication system. So initial cost of satellite is, orbit is very high. So as we have discussed that satellite communication speed is very high. Atmosphere disturbances like thunder, lightning affect the Ku band transmission of satellite communication system. So in this what we use? We use C band transmission is recommended during the bad weather. So we have K band, so we have different kinds of banding techniques. So if the weather is normal situation, we use K band. If the weather is not in a normal situation, we use the C band. So these satellites are basically purely work on the space, right? Purely on the space. So it depends upon the weather. Yes or no? So if the weather is somewhat cool, so the sunlight is very bright, so what we do? We may feel somewhat difference. Similarly, satellites also, if the weather is perfect, then only it can transfer the data with a high speed to the receiver. If the weather is not proper to the satellite, then it also not sends the data. So what we have to do? We have to changing the system of the satellite from K band to C band. Clear this one?